This is the assignment quotient of monomials and zero and negative exponents worksheet. So this is going to be covering division of monomials that involve variables with exponents and those exponent rules that we've been applying. And we have a foldable that has all the exponent rules. I'm putting a PDF of this foldable information online right with the video in Google Classroom. Okay, just a quick reminder, the number in front, the big number we call it, is the coefficient, okay? Exponent rules do not apply to these at all, okay? If you're multiplying in a problem, then you multiply these numbers. There's no special rules for these except do the math, whatever math is happening, okay? This is the exponent, and these are all the special rules we've been learning apply to these numbers. The number or variable that has the exponent is called the base. The first rule we learned, which we actually learned at the beginning of the year, when you combine like terms, the exponent and the bases have to match exactly. We called this having the same last name at the beginning of the year. For example, if I have 3x to the third plus 4x to the third, I would say my last name is x to the third, and I just add the 3 and the 4 together to get 7. That was the beginning of the year stuff. That still applies. That doesn't change at all. That is when you're adding or subtracting these guys. What we've been doing recently is multiplying and dividing. Those are where the new rules come in. Okay, so, for example, if I am multiplying a to the second times a to the third, my exponent rule tells me to add these exponents. 2 plus 3 is 5, so I get a to the fifth. Okay, I'm not multiplying that to get a to the sixth, I'm adding that to get a to the fifth. So when you multiply these monomials, you add the exponents. When you divide these monomials, you subtract the exponents. So 5 minus 2, I get a to the third. Okay, so those are two of the rules. The negative exponents. The thing that we taught you in class is get rid of the negative exponent by writing it again. If it's upstairs or in the numerator and it's negative, rewrite the problem with it downstairs in the denominator. This a to the negative 2 becomes 1 over a to the positive 2. All right? This 2b c to the power of negative 4, we move this c to the power of negative 4 downstairs. We get 2b divided by c to the 4. Excuse me. So that's how the negatives work. If it's upstairs, move it downstairs to make it positive. If it's downstairs, move it upstairs to make it positive. Zero exponents. Anything to the 0 power, almost anything, we don't count the number 0, but anything else besides 0 to the power of 0 becomes 1. Okay? So x to the 0 power equals 1, and so on. The last one we're going to cover, because the other ones we're not doing much with, power to a power. An exponent with its own exponent. When you have an exponent hanging on the parentheses, that is when you multiply these. So x to the third raised to the power of 2. We do 3 times 2, and you get x to the 6th. Okay? It's a lot of rules. We have spent a lot of time on them because we know it's a lot of rules. Let's go ahead and give you some more help here on the video. I'm going to do all the odds on this assignment. So for this one, we have 12a to the third divided by 3a. Okay, so the big numbers are the coefficients. I do regular math with that. 12 divided by 3 is 4. But with my bases that have exponents, I use my exponent rules. a to the 3 minus 1, we get 3 minus 1 is 2, so you get a to the 2. Now since there is nothing in the denominator anymore, we don't even have to write the denominator, so we can just consider that as the answer. 4a to the power of 2. Number 3, we have 45 s to the 7th w divided by 15 s to the 5th. We're going to divide these. Regular division, because those are not exponents. 45 divided by 15 is 3. Let's take care of our s's. We have s to the 7th on top, s to the 5th on bottom. 7 minus 5 is 2, so you have s to the 2. And you still have w. Okay, there's nothing on the bottom, so we don't have to worry about writing the denominator. It's like there's an invisible 1 down there. Number 5, you have negative c to the 5th, d to the 3rd, divided by c to the 4th, d to the 3rd. Now this negative is not an exponent, so we don't have to take anything downstairs. That's just a negative 1 coefficient in front. Okay? So we still have a negative in front. C to the 5th and c to the 4th, you do 5 minus 4 and you get c to the 1, or just c. D to the 3rd and d to the 3rd cancel. So all we have left is negative c. That's the answer. Number 7. Let me fold this so I can fit it in over here. We have 66w to the 3rd, x to the 6th, divided by negative 33w x to the 2nd. As soon as I see something without an exponent, I try to remember to write a 1 there. Okay, let's take care of our big numbers first, just doing regular division. 66 divided by 33. You can put that in your calculator if you want. It's going to give you negative 2. On top, because I had most of my number stuff on top. W to the 3rd divided by w to the 1. 3 minus 1 gives you w to the 2nd. 3 minus 1 is 2. X to the 6th divided by x to the 2nd. 6 minus 2 is 4, so you get x to the 4th. I don't have anything left on the bottom, so once again, I don't have to write the denominator. I can just keep that as my answer. Let's check out number 9. Number 9 is a multi-step problem. You have two things on top you have to multiply, but you also have to divide it by this denominator. What I want to do first is ignore the bottom completely and just tackle this one first. This is pretty straightforward. 3 times 2 gives me 6. That's just regular multiplying of the coefficients. And now I have some exponents I have to apply exponent rules toward. So I have x to the 4th, y to the 1, x to the 1, y to the 2. Let's look at my x's first. X to the 4 and x to the 1, 4 plus 1 is 5. I get x to the 5. Y to the 1 and y to the 2, 1 plus 2 is 3. I get y to the 3. Okay, so I'm not done. I just took care of the numerator upstairs. I still have 12 x to the 5th, y to the 2nd. Okay, so I'm going to divide 6 divided by 12. Some people do that quickly and say 2. But if you get 2, you're doing it backwards. You're thinking 12 divided by 6. 6 divided by 12 is actually 1/2. 6 is half of 12. All right? X to the 5th divided by x to the 5th, they actually cancel out completely. The x's are gone. Y to the 3rd divided by y to the 2nd, 3 minus 2 is 1, so we just get y to the 1 on top. Now we don't have to write this one, it's understood. We don't have to write that one, it's understood. So our simplified answer is y over 2. Let's take a look at number 11 in the middle here. Okay, we have another multi-step problem. Now, this 3 exponent is on the outside of some parentheses, so we need to take care of that right now. Now, this is a negative 1, and then 1 is invisible. I'm going to write it in. So you have negative 1 to the power of 3, and you also have a to the power of 3. Negative 1 times negative 1 is 1. And then 1 times negative 1 again goes back to negative 1. So doing that math, we just got negative 1 again. And then when I distribute this exponent 3 to the a, I get a to the 3rd. So it doesn't look like a lot happened there, but we did have to do those steps to get rid of the exponent on the outside of the parentheses. Now I can rewrite the problem, the rest of the problem in b to the 8th divided by a to the 3rd, b to the 7th. The -1 stays. I still have -1. The a's cancel because they're both a to the 3rd. And with the b's, I have 8 minus 7. It gives me b to the 1 on top. I don't have anything left on bottom, so I can simplify my answer and say I have -b. That's my answer. Because the 1's are invisible. Okay, you know what? I did number 8, and now I didn't even have to. That was an even. That was a bonus question, I guess. Sorry about that. Let's do number 11. 16 divided by 8 is 2. Oh, you know what? I need to actually, before I jump into that, I need to get rid of these negative exponents. I'm going to rewrite the problem. This x to the -2 goes downstairs, and it's x to the 2. This 8 stays. This x to the -7 goes upstairs, it's x to the 7. And this y to the 0 stays. Okay, now that I've done that, let's do the math. 16 divided by 8 is 2. 7 minus 2 gives me 5, so I have x to the 5th on top. And y to the 0 is 1, because anything to the 0 power is 1. So all I have down here is 1. My simplified answer is 2x to the 5th. There you go. Let's check out number 13. The directions say evaluate each expression for the given value of the variables. So basically we have some variables, and then we have the value of those variables. We're going to plug these numbers in. So for 13, I have a to the 5th times b to the -6th. Okay? Well, first of all, let's rewrite it to get rid of the negative exponent. That would be the same thing as a to the 5th over b to the 6th. Now I no longer have a negative on that 6th exponent. But now I'm going to plug in my variable, my numbers for my variables. A is 3, so it's really 3 to the 5th. And b is 2, so it's really 2 to the 6th. I can put this in my calculator. Let's see. I'm going to put in 3 caret top 5. But remember, when you put this in, you always want to put it the base number in parentheses. So 3 in parentheses, and then this button right here. That's my house top. It's my exponent button. To the 5th power. 243. That's my top number. And then 2 to the 6th. 2 to the 6th. 64. Now, you could put this in the calculator to see if it reduces, but I want to show you something else. You can actually put this entire thing in one step. It'll give you the final answer. Let me show you that also. I'm going to go do control divide to get my fraction template, and I'm going to put in 3 to the 5th divided by 2 to the 6th. So 3 in parentheses to the 5th divided by 2 in parentheses to the 6th. Push enter. That's the same answer, and since it didn't reduce it down to something else, that's as reduced as that can get. So that is my answer. Okay, one more and we're done. The area of a rectangle is 16x to the 18th, y to the 6th. If the width of the rectangle is 8x third, y third, z to the 0, find the length. So here's what we're doing here. And I'm going to run out of time, so I'm going to get as far as I can before I have to stop it at 15 minutes. This is my area. It equals length, which I don't know, times width, which I do know. Okay. 8 times what is 16? 8 times 2. And x to the 3rd times what? Plus what is x to the 18? You add those, it'd be x to the 15. And y to the 3rd and y to the 3rd add to get y to the 6th. So that's your answer. Z to the 0 becomes 1.